Good evening, everyone. My name is Mark Wootton from Sharmans Pikesday branch, and I have the pleasure of being at our headquarters at Grantham this evening to introduce you to our live Combine Focus evening. Now, I emphasise the word live, so the bloopers and the outtakes are at no extra charge. At the end of this evening, there will be questions and answers asked to our guests, so please feel free to ask questions as we go, but they will be answered at the end because hopefully we'll cover some of them on our journey around the combine behind me, which is our demonstration Case 9250 flagship combine with 636 horsepower at its disposal. We're going to learn some of the secrets that make this one of the lowest operating cost combines on the market, along with one of the very highest outputs. Those of you that run 100 series or 200 series case combines will already know a lot of the secrets, but for everybody else, we're going to find out why if you talk to your grain merchant, he will tell you that this combine will crack less wheat and skin less barley than any other combine on the market. We're going to take a journey of the crop from the front through to the back of the combine. I am joined this evening by Robbie McCard, who is the Case IH UK Harvesting Specialist, who will be taking over from me shortly. We also have Ed Watson, who is Product Specialist and Demonstrator for the UK. And we also have Andrew Channing, who's a colleague of mine from the Loudon Depot. So together, we're going to try and give you as much information over the next 20 minutes as we possibly can. Now, starting at the front of the combine, Case IH, we can now order the whole range of 30 series heavy duty headers direct from the factory on a trolley, which makes logistics and handling much safer and convenient for everybody. They are available from 15 foot right up to 41 foot wide. Remember, Case were the very first manufacturer to offer a truly controlled traffic at 12 metre compatible combine. Starting at the front, we have 570 millimetres travel on the Vario header. We have a wide diameter deep flighted auger for smooth ingress of the crop to the long elevator, which we'll look at in more detail later. We have a hydraulically driven reel, which is capable of working considerably in front of and below the knife. So for tough laid and lodge crops, it will really stand them up and drag them onto the header. As we move back behind the combine, you will see that the shaft drive, right from the engine, shaft driven right to the front of the header, and the single point latching will be visible to you shortly. And the shaft drive means that we have a full reversible header function as well. At this point, I am going to hand over to the UK Harvesting Specialist, Mr. Robbie McCard.
Thanks very much, Mark. Good evening to everyone. Thank you for joining us on this live occasion. So I'd like just to carry the story a little further, really, with regards to an axial flow combine. We want to start really where Mark has left off from the back of the header. First of all, we'd like just to have a quick look at the tracks. We've been specialising in tracks really with combine harvesters for the last 7 or 8 years. But specifically in the last 3 or 4 years, we've standardised then with a self-suspension track system. We're featuring this evening a 24-inch track, but we have other tracks available as well. We have a 28.5-inch track and a 34-inch track, should soil compaction be a real problem to you. The point with tracks is that it gives you stability as far as field access is concerned, but also with regards to the header height control as well. It gives you an absolutely stable platform. And bearing in mind what Mark has just said that we do with controlled traffic farming 12.5 metre headers, that's a crucial component. So as we paint the story of our combine, we'd like to link a few things together. There's a little bit about the header, a little bit about the tracks. We're going to have a look at the grain tank and the unloading system in a moment. And finally then, to finish that part of the story off, we're also going to have a look at residue management as well and handling. But before we get that far, we really now want to concentrate and have a look at the rotor mechanism itself as far as the combine is concerned. So as the camera moves in a little closer, we just give you an idea of what we're looking at in here. From the concept of an axial flow combine, we've always had a single rotor, and we first went into commercial production in 1977. Now, in fairness, over the years, there's been many changes and improvements, but specifically for us in the European markets, from 2008 onwards, we then fitted what we call a small tube rotor. And this really then standardized our combine for European markets, European conditions, and European cropping. And without fear or favour, what we can guarantee is that you have a combine here that if it's a combinable crop, we can harvest it. We're absolutely confident and in our argument on that point, bearing in mind that if you are thinking about changing a combine, you need to think about being future-proof. And the point that we're trying to make is that you have a combine here that can literally harvest anything. Now, the thrashing system itself, again, comes back to a single rotor design. We have the ability to change the rotor speed, clearly, and we also have the ability to change the concave clearance, of which we would refer to them as modules, and these are mounted directly underneath the main rotor itself. We have in the region of 180 degrees separation, but more importantly, coming back to specialist crops and so on, we can actually change the modules and change the configuration of the rotor, again, to cater for any different type of crop that's coming in the future. And again, this gives us this capability really of being future proof. Now, one of the other components as well that's very important with our rotor system is that it's also reversible. And the point to that is that if you're trying to push maximum capacity out of the combine, and it's a more difficult harvesting season, and should you push it to the limit and then block the combine up, and like other models or other makes on the market, we can actually then deslug the rotor system. And basically what we can do then is we can reverse the rotor, loosen the crop, and then allow the crop to come back through again. The point to it is it actually minimises the downtime, but more importantly, if the operator does get it wrong, it's a very simple fix from the operator's platform to actually rectify what he's done wrong and then go again. So again, it's just a driver aid as much as anything, but more importantly, to maximize the performance out of the machine. So staying with the theme actually thrashing and separating, the next major component then really is the sieve box as far as cleaning and producing a sample. So what we have here is a self-level shoe system which combines the main fan itself, the fanning mill. We have a pre-sieve, a top sieve and a bottom sieve, which are all automatically controlled and from the cab manually as well if required. But the point is it's a self-level shoe. So as the combine cuts across the slope, it will automatically compensate for the angle of the slope. And more importantly, the fan speed is also adjusted automatically as well if the combine goes uphill or downhill as well. It's an automatic feature that we have as standard equipment. Now, once we've got the grain thrashed and it's clean and it's transported into the main grain tank itself above us, on our bigger machines, featuring here the 9250, we actually have a capacity of 14,400 litres. But it doesn't just stop there. Part and parcel of Mark's introduction was about the larger headers. In conjunction with the larger headers, we need larger capacity discharge augers and lengths of augers, so we can actually fine-tune the auger length to the cutting width of the header that's actually fitted. More importantly, discharge times are also very important as well. So we have a maximum discharge rate of 159 litres per second, which is phenomenal. It's one of the biggest on the market. But in addition to that, which is also a very unique feature as well, we have a dual drive system. And you can probably just make out there's two drive lines here, two different chain systems. Now, when you first engage the main unloading auger, it's just the unloading auger that starts itself. Followed a few seconds later by the sweep augers or the belly augers in the bottom of the grain tank that then feed the main discharge auger. And it's those sweep augers that we then control to top off a trailer, or if you will, to stop and start the flow out of the main auger itself. Now, the real point to this system is that because of obviously bigger headers, bigger capacities, and bigger lengths of as far as the unloading auger is concerned, we need to actually have more control when we stop and start the main table or main auger itself. By stopping the sweep augers first, it means the unloading auger, the main unloading auger, always runs empty. So next time you come to start it, and particularly in very wet or more difficult conditions, the unloading auger then starts on a no-load situation, which is a win-win for everyone. So to continue the theme then, what I'd like to do now is move towards the rear of the And all these points that we've discussed rather, we will actually go through in a little bit more detail in a few moments. But trying to link the components together now to make a little bit more sense of it all, we've talked a little bit about the headers, we've talked a little bit about the unloading systems and the grain tank. But of course, the bigger header then gives you bigger problems as far as residue management is concerned and straw handling, particularly if straw is a nuisance to you. So what we've been doing over the last few years is developing what we call a super chopper, a ready chopping system, which actually gives us the ability to really finely chop, but most importantly, distribute to the full width of the header that chopped straw. And the point to it as well is that it's an even spread. Even with our largest headers, and our draper headers now are 45 foot, which is 13.6 meters, we can guarantee distribute the material to full width of the cutting head. But most importantly, it's not just about the full width of spread, it's the evenness. Because what we're really trying to say is, and what we're trying to feature with the combine, is it actually then starts to perform as part of the cultivation process or the new crop establishment process, really starting with the combine, particularly if you're then looking at min-till or no-till situations. And we know that's one of the features that a lot of UK farmers are now looking at and actually strongly featuring on as well. So as far as my presentation is concerned, we're coming towards the end of it. So what I'd like to do now is hand over to Andrew. And Andrew's going to go through some of the key points that we've just mentioned in a little bit more detail and actually physically start to show you some of these real key areas, just as a bit of a teaser as much as anything, so that gives you a bit of an idea of what we're trying to show and explain on tonight's programme. So again, thank you very much, and I'll hand over to Andrew. Thank you again.
Good evening and welcome to the programme tonight then, looking at the Axial Flow Combine, our lovely demonstrator. So Ed's going to help me now and we're going to demonstrate some of the really good features on the Axial Flow Combine. So we've got the header faceplate tilt system on the front here, and basically Ed's going to demonstrate how you can tilt it forwards and backwards. So if you've got some late crops and hard conditions, we can use this to really shave the stubble to try and pick up as much crop as possible. But to be fair, with the case header, it is fantastic in laid crops. You don't even need lifters. You can do a better job without lifters picking up laid crops. So that's an extra feature on the case combine. Thank you very much, Ed. That's brilliant. Okay, so we move to the heart of the machine. So now we are going to demonstrate basically our rotor reverse system. So Robin told us about it earlier on in the programme. So we can reverse the rotor. Fantastic feature. If you do get a blockage and you do push her a little bit hard, we can reverse her and we're not all day unblocking the combine. How good is that, eh? Really cool. So thank you for that, Ed. And now we move to the rear of the combine then. So earlier on in the programme, Robin talked about the chopper on the back of the combine, and it's fantastic. We have got a right and left spreader plate. So basically, if we have these massive 40-foot headers, we can basically change the right and left spreader plates and distribute where we want the residue to go out the back of the combine. So it's fantastic. It really is. And also, when you get into the back of the combine to go and do servicing, you drop the plates right to the floor and pull your ladders down, and there you have it. Straight up there, easy access to the rear of the combine. So now we are going to work our way back round to the side of the combine, and Ed is going to tell us about a really cool feature that operates from inside the cab and on the side of the machine too. It's really cool technology.
Thank you very much, Andrew. So I'm going to talk to you about Harvest Command. So what is Harvest Command? Harvest Command we introduced to the flagship combines last year, and what it is an automated system. This allows the combine to alter settings, all settings involved such as your rotor speed, your sieve clearance opening, and your fan speed, anything to do with the combine, including forward speed. As conditions change, whether that be crop, the field conditions, inclination, the combine will adjust these settings to maximize efficiency. Therefore, the driver is reduced stress and less fatigue, and he can concentrate on the job in hand, overall improving the whole performance of the combine. How does it do it? So we use existing hardware on the combine. So we use rotor loss sensors, we use the sieve loss sensors. We use the inclinometer underneath the cab, so that will control the fan speed as we go up and down hills. What we also have is a grain camera. This grain camera takes a sample from the clean grain elevator. This grain camera can distinguish cracked grains and also MOG, material other than grain. So therefore, we can adapt the settings, such as the cleaning system or the thrashing system, to try and reduce the cracked grains or limit the material in the sample. Other sensors that we have introduced onto the combine are some air pressure sensors on the sieve area. This is measuring the air pressure and measuring the differential between the upper sieve and lower sieve. Then it's making adjustments to the fan speed and sieve opening and closing to maximize that air pressure differential to maximize the performance of the cleaning system. What else does it bring in benefits? So who does it benefit? So an experienced operator, is it going to benefit them? The answer is yes. In the short term, an experienced operator may be able to control the combine just as good as this system, but across a 16-hour day, concentration lapse, he gets fatigued, and then the system will take over and the performance will be increased with harvest command. An inexperienced operator. Yes, we can use this combine with an experienced operator. The harvest command system will maximize the performance and get them up to the performance of an experienced operator in a short space of time. As conditions change, the settings will change, and he is going to be performing just as your best operators will do on a full 16, 12-hour day, whatever we're doing. So what does the operator do? He has to select a strategy. So the strategy, there's 4 strategies. One is the grain cam. So it's going to use use the camera here to maximize the performance and maximize the sample in the tank, limiting cracked grains, limiting material other than grain in the tank. Another strategy he might want to work at is maximum throughput. So this is maximizing the throughput of the combine, keeping it at maximum engine load and keeping it maximum performance. Another strategy we might seem to want to use is fixed throughput. So if your grain system in the barns and in your elevators, your cleaning systems can't cope back at the farm, what we can do is we can say run the combine at 40 tonne an hour, and then we will be at a fixed throughput of about 40 tonne an hour all day. So therefore, grain trailers, all of the logistics back at the farm can keep up with the combine. We're not wasting any time. And then the final strategy that the operator might choose to use is performance mode. And within performance mode, what he's trying to do is maximize the performance of the combine, so maximize the throughput, but also taking into account losses. So that's when we're taking into account the losses over the rotor and losses over the sieves to maximize the throughput of the combine, but then also trying to minimize the amount of grain on the floor. So that is Harvest Command, available on all the flagship combines. So I'm going to ask Andrew back and also Robin, and we're going to have some questions from the audience, please.
Right, okay, so we're going to do some questions then from you lovely guys on Facebook Live. So the first one then, gents, what about the straw quality then, Robin and Ed? What's your thoughts on the straw quality out the back of an axle flow?
Well, that's a very fair question, and probably falls to me to answer that question, really. Going back to the beginning of the presentation, I said that with the rotor design, we changed that in 2008. And not only does it give us more capacity, more capability to handle all different types of crops in the European conditions, but at the same time, actually, it was one of the major considerations as well to actually improve the straw quality. And we addressed that at that point. Now, again, it also comes down to the operator and how you've actually set the combine up. In a sense, we have rotor speed that we can still change and finalize. We can change the concave setting as well to improve the straw quality. We can also change the actual modules themselves. So depending on what crop it is and the conditions, we can actually improve the straw quality from that point of view. In addition to that, one of the major changes we made for the 250 series with the introduction of Harvest Command is that we can now alter the vanes inside the actual cage unit itself. So we have a series of vanes that's mounted on the inside of the cage that actually then help the material spiral through as the rotor turns. The point being now is that we can change the angle of those vanes from the cab or automatically to actually increase or decrease, if that makes sense, the number of revolutions of the rotor relevant to the straw that's going through the combine. The net result of that is that you can actually improve the straw quality. So, short resume, if we look at a normal harvest conditions, UK harvest conditions, particularly in wheat, where it's come wet and dry, finally comes dry, and the crop is really brittle and dead completely, if that makes sense. At that point, it doesn't take so much thrashing. So what we can do then is alter the vanes to actually get the throughput of the straw through much quicker and therefore preserve the quality of the straw. In addition to that, going back to the ready cop on the back of the combine, while we didn't mention this point, the ready cop also doubles up as well to handle swath straw. And one of the nice features with the ready cop is that once you go to swathing, which again you can change from the cab, you don't have to get off the combine seat to do that. But once you've gone into the swathing mode, first of all, we have a power ejected roller at the back that actually positively feeds the straw flow out of the combine. But more significantly, we have a pair of swath gates at the back of the combine as well to actually sort of mirror down, if that makes sense, and squeeze down the actual straw swath that comes out of there. And without fear or favour, the straw pattern that you get out of the back of the combine is absolutely superb. So it's a proper box section. So if you're doing a lot of baling, be it round balers or square balers, bearing in mind we do both, the straw quality actually is greatly improved. So I hope that answers the question. Thank you.
Fantastic, thank you. So, next question then. Is the combine suitable for being used for seed quality standards? Do you want to do this one, Robin or Ed?
Yeah. Okay, so thanks again. Well, I'll have another go at this one for you. Yes, seed quality is very important. Again, when we changed the rotor design, as I say, back in 2008, part and parcel of that, again, was to ensure that we could handle every crop. And one of the nice things about our combine is the way in which we thrash our material. We generally work on what we refer to as thrashing crop on crop. So it's much more of a gentle action. And this in itself actually lends itself to seed production. It means we get less skinning of the external berry, if that makes sense, itself. But also it lends itself to seed production for grass seed as well. And it is a little unknown fact that most of the combines sold in the Danish markets are actual flow combines, bearing in mind that's where most of the grass seed actually comes from. So again, I think that's a clear indication that we have absolute confidence and customers have confidence in axial flow combines producing good quality, high germination rates of seed for seed production. So again, I hope that answers the question. Thank you very much.
Fantastic. And last question then. Can the combine be fitted with auto steer? That's probably one for Ed. Yeah, there we go, Mr. Techno.
Yes, the answer is yes, for sure. With Harvest Command, obviously, we're getting the automation of the combine, so we need to automate the steering, again, reducing the fatigue of the operator. So all combines come AccuGuide ready, and then the option is to complete them. So to have an AccuGuide complete combine, we 372 antenna in the tank in a safe position, which is not vulnerable to theft. And we also have a nav controller mounted underneath the cab. This nav controller compensates for the terrain, so we're always keeping on track no matter what the terrain is. We can offer the guidance to varying levels, so we can have your basic EGNOS system accurate to probably 20 centimeters accuracy, but not repeatable. We can then go to a range point signal, which is down to about 15 to 10 centimeters accuracy. We can offer a center point accuracy, which is 3 centimeters accurate, and becoming to get repeatable year on year. We can start to use the same tram lines, important with controlled traffic, and then the ultimate goal is RTK. So we can offer down to your 2.5 centimeter accuracy, and Case IH offer an RTK plus system throughout the whole of the UK, so we can get RTK wherever you are in the country.
Fantastic. Thank you, Ed. Okay, so that just about wraps up the programme. I hope you've enjoyed this evening, and thank you very much for taking the half an hour we've been live here on Facebook. A big thank you to Ed and Robin from Case, and also Mark from our Pytchley depot. So if you'd like any more information on the Case Combine, the Axle Flow, please do talk to your local sales rep. And there's obviously information online on the Case website and on our website as well, sharmans-agri.co.uk. And don't forget, we've got our brand new website, so take a look. We've put a lot of time into it, and it's really, really good. Fresh new look for Sharmans. So there we go. So thank you very much for watching. Have a nice evening. See you again soon. Thank you.